Assalamualaikum warahmatullahi wabarakatuh. Okay, kita sambung lagi perbincangan kita untuk exercise 2, chapter 2, question number 3. Okay, for question number 3, two impedances Z1 and Z2 and a single phase motor are connected in parallel across 200 volt RMS with 60 Hz supply as shown in figure below. The motor draws 5 kV ampere at 0.8 power factor, lagging power factor. The question is find the complex power S1, S2 for the two impedances and S3 for the motor. Okay, first of all, you need to draw the equivalent circuit. Okay, equivalent circuit and put all the related information to the circuit. Okay, in this case we have a supply voltage 200 volt. Please bear in mind this 200 volt actually is RMS voltage with frequency of 60 Hz. And then we have a Z1 equal to 0.8 plus J5.6 ohm. And then we have a Z2, impedance 2, 8 minus J16 ohm. And then for load number 3, we have a motor with apparent power S3 equal to 5000 volt ampere or 5 kilovolt ampere. This is apparent power at lagging power factor 0.8. Okay, 0.8. So the question is how to determine S1. Okay, complex power for load number 1, S2 complex power for load number 2, and S3 complex power for the load number 3 or for the motor. Okay, so complex power, so as we know, complex power equal to S equal to VRMS IRMS conjugate. Okay, but in this question we have a Z1, we have a impedance, and then we have a voltage. So we can calculate the complex power according to the voltage and impedance, because S equal to VRMS IRMS conjugate, we can derive from here. So we got the VRMS times VRMS over Z equal to current. Okay, VRMS times VRMS conjugate equal to VRMS square. So S equal to V square over Z1 conjugate. Okay, we have amplitude of voltage, and then we have a Z1 conjugate. Okay, Z1 from here, so conjugate, so we can get the S1. We can get complex power of impedance 1 or load number 1. Okay, similarly for the load number 2, we have a V square over, we have a V, so V square over Z square conjugate, so we can get the S2 complex power at the load 2. And then the last one, we can calculate the complex power of the load 3, okay, of the motor. Okay, given apparent power S3 equal to 5 kilovolt ampere with power factor equal to 0.8 lagging power factor. Lagging means inductive load. Please remember, lagging equal to inductive load, leading equal to capacitive load. Okay, so we have a we have a S apparent power equal to 5000, angle equal to inverse cos 0.8 equal to 36.87 degree positive. So you can use your scientific calculator to transform from polar form to the rectangular form. This is the real power, and then this is the reactive power. Okay, so we can determine S1, S2 and S3. Okay, so from the S1, S2 and S3, we can determine the total complex power from the energy conservation. Power supply equal to power consumed by the load. Okay, S total equal to summation of S1, S2 and S3. So we can get the total complex power equal to 10 angle 53.13 kilovolt ampere. Okay, so next we move to the question number 2, question 3 to 2. Okay, determine the total power taken from the supply, determine the complex power taken from the supply, and determine the supply current. Okay, we just calculate the total complex power supplied by the source, and then we calculate the supply current, I, capital I, this I. Okay, so we already calculate the total complex power. Okay, S total equal to 10 angle 53.13 kilovolt ampere. So from the S, okay, we can calculate the current because S equal to V RMS times I RMS conjugate. Okay, so we can determine the current I RMS equal to S conjugate. Okay, S conjugate, you can see minus. Okay, this is positive, this is negative. Okay, because of conjugate, divided by V conjugate. So we can get a current 50 angle minus 53.13 ampere. Okay, so this is the supply current. So maybe the next question is determine the power factor. Okay, determine the total power factor seen from the source. So since we have a total complex power equal to 10 angle 53.13, so power factor seen from the source equal to cos theta equal to 0.6 lagging power factor. Why lagging? Because angle of the complex power is positive, which is inductive load. Inductive load, lagging power factor. So I think that's all for question number 3. So thank you very much.